This conference will now be recorded.
Okay, so let's get started, guys. So last class we have been into seeing your Docker concept, right? And using your CI/CD pipelines, we are able to deploy the things with your web application successfully, right? And now let's move on to the next concept of Kubernetes. So, one second, please.
Hello. Shyam, I'm not able to hear you.
I'm sorry, guys. Call. Right. Anyway, so Kubernetes. So this is like kind of a advanced, I would say, concept for Docker. Okay. So till now, within your Docker level, we have we used the kind of like the containers, the images, all those things in here. So for example, think that we have like hundreds of containers running in here within your Docker level. So within your Docker host level in here. So now certain thing that all of a sudden, one of the Docker or one of the container what you have is been down. So what you do in generally, you can manually go over there and you can see what's issue and you can bring your Docker up and running. Or if you want to do what you can do, so you can pull one more instance of the image and you can run a different container. So that you can have that key up and running in here again. So first one or two or probably 10 or you can manage. But think that all of a sudden the total the kind of the Docker host is down itself. So like the total all the containers what are running in the Docker are down. So in that scenario, manually we cannot we can't able to manage all those in a single point of time. So we need a very big thing where it can manage the things and we can make the things up and running automatically in here. So who can do that? At the same time, for example, now I want to create my multiple Docker host. I want to go with my multiple environments in here, multiple Docker host. So who can, if you want to do that, you can do it manually. Or generally, when you have when you have big issues with your Docker containers in here all here. So instead of running in one Docker host, instead of running in one Docker host, what you do, you can go ahead and you can you can create one more Docker host which is running in parallel. Just in case when anything happened to my the initial one, then automatically what happens, you can go with your secondary piece in here. So this is again maintaining the things manually. It's not a small thing, guys. So it's very hectic to do creating of multiple Docker hosts, running the containers, multiple Docker hosts in here, the same kind of backup kind of things in here. So doing all those things manually is not a small part. So to make it automated way, to make these things happen very quickly and in a smarter manner, who can do that? Your Kubernetes can go ahead, and this is the one who can go and they can maintain the Docker instance. So Kubernetes is the one. Suppose you enter run a container. So Kubernetes is the one who can decide where that can be, installed, which container that is to be deployed, in which Docker host it can go and run the container in here. Because everything will be managed by Kubernetes in here. So when I go with my Kubernetes environment, so I don't want to do anything manually. I want to push everything to my Kubernetes so that we can easily so that it can easily manage things in here. Okay, so one second. So it can easily manage things for you as in here, and so that it can take care of the things and which has been causing unexpectedly all the things in here. So Kubernetes is a kind of a manager to my Docker, where it can go ahead and it can have things run in a smooth manner in here. Okay, so now when you talk about the Kubernetes, now what is your architecture of the Kubernetes in here? So the architecture, coming to architecture in here. So earlier, if you see with respect to my Docker, I have something like Docker CLI. So what we have in that, because I would like to push my commands because I ran some kind of commands manually with my Docker first, and then we made it automatically. Similarly, within your Kubernetes environment as well, we have some kind of things where you can run manually. Like I want to see the pods. So when you talk about the Kubernetes, the terminology will may change. Nobody will talk about your containers, or nobody will talk about images in here. We're talking about your pods in here. Okay, your pods, your services, your deployments, all those things comes into picture with respect to my Kubernetes. So to manage that particular stuff in here, what we need, so I need I need a kind of a CLI with respect to my Kubernetes as well, and that CLI is called as my kubectl CLI in here. So why do we need the CLI in here? So we need this one because I would like to send out my commands. So CLI is used to send out the commands for to manage or to Kubernetes to manage the the containers or the what are things you have in here. Okay, so do all those things. You can have your the CLI engine. The kubectl is a very important. So I'll tell you how can you go ahead and how can you can use your kubectl CLI, which is similar to your Docker CLI in here. So that is different and this is different in here. So next, once you have you provide your once you provide your commands in here, so when you tend to run your commands in here, so they should be who should take care of your commands in here, right? So earlier when your Docker host, when your Docker hub, so you are over there, we have Docker daemon who's trying to take all the requests from from your Docker CLI. Similarly here with respect to Kubernetes, who is trying to maintain the things, who is trying to take care of the request what you have in here. So here the thing which has been trying to maintain or which is trying to process the request as per our requirement is called it's called as the master. Okay, it's called as a master engine. So master is the one who is trying to process the orders from what you get from your CLI in here. Okay, so this is the one. So master is what is trying to just process the orders. It never implement any kind of request from CLI what we get. It never implement, but what it do, it will try to simply process the things in here. For example, or generally if you go to a restaurant, for example, so general restaurant, you can see, one person who's wearing the tie and he'll coming to you and, so he'll try to take the orders from you. So he's like a what? Is a captain. He's like a captain of waiters in here. Captain of waiters in here. So who is trying to take just the orders? He will just process the order only, but he will never implement. He never go to the kitchen directly, and he never deliver the food directly to you in here. So captain is what? He is trying to lead your. He's trying to lead your waiter. That's it. He'll try to see which waiter is free in here, or or which waiter has been already busy in here. So which weight is not available in here, which weight is been available in here. So we'll try to look all those things in here, and finally based upon that, what he will do, he will try to go and send those orders to my respective waiters what you have in here. So these waiters, what they'll do, they'll waiters receive the order from my captain, and these waiters will try to process process the order, and deliver the food to the customers. Correct? So this is generally happens when you go with a restaurant. Similarly, here as well, the master is nothing but like a captain of my waiters, who is trying to take the orders from my CLI. I will take the commands from my CLI in here. They will never implement any kind of request in here. They just try to go and take the orders from my wait customers only. So what captain will do, he will check which weight is free in here, and based upon that he can go ahead and what he can do, he can you can process the order and deliver the things within with respect to my things in here, right? So similarly here, who are waiters? The waiters are nothing but called as my nodes. So nodes are nothing but my waiters who will who will process the request where they got from where, from my master. So your node doesn't know who has requested this particular the command, what are the process they want to go with, the work they want to go with. Nodes only what they'll try to go and check, do we get a request from my master or not. So if they get the request, automatically we'll try to process, nodes will try to process the request which is getting from a master in here. So nodes or waiters are the same in here. The master or my captain of my waiters are similar in here. Okay. So up to this level, any questions, guys? The CLI, your master, and the nodes. Okay. So let me go with your diagrammatic way so that you can have a deeper look of your architecture. So what is this one? This is nothing but my kind of a cube CLI, a cube CTL, or it's a kind of a CLI where I can run my commands in here. So who is he? He is the one who's trying to, who's trying to send out his request using your CLI in here. So once this one pushed and from where this to where this particular request will be going, to my master. So within the master, you have, as you know, within the Docker, you have Docker daemon, right? Similarly here as well, within my master, we have one main component called as API server at the backend. So this is one of the component of your master where all your requests will be sent into my API server in here only. Okay, of course we have a lot many other components available within a master as of now, so it's not required to bother about all those things, but we mainly work on your node systems. So master will not be taken care by you. So once you try to create your nodes, automatically master will be created at the back end, and this will be managed by your Azure. So we do not have any control over your master. Okay, please keep this in mind in here. So apart from this one, you also have something like some kind of controller, or here we have kind of some kind of controller. At the same time, you have your kind of small internal things. We have a scheduler, all those things in here. So, and also you have some kind of a database available as well. So within your Kubernetes environment to handle your things within your Kubernetes level in here. So all those things, so which has been handled by a same API server. So, but these are internal parts where we are not bothered about this particular part at all in here. The main thing is like we are trying to look into your API server where this is trying to handle, this is trying to process the orders what you get from your kubectl in here. So overall, this would be your master. So this is my master in here. So what my master will does? So does it process the orders which is received by kubectl in here? No. So what it will do? It will try to provide it will try to push the same request what you get from kubectl to where, to my to my nodes in here. So node is nothing but it's a kind of a waiter who's trying to process your actual order receiving from my API server what you have in here. So what you have in where now how your nodes looks like. See here within my node level, the main thing as you have API server to receive the request from your kubectl CLI. Similarly, I have one component available at my node level, and this is called as my kubelet. Kubelet in here. So this is like one of my component within my node level, which is trying to get all the requests from my API server. So kubelet is the responsible to make the things happen as per the request mentioned by your kubectl from your kubectl CLI in here. So what generally we have in general, when you talk about the things in here, we'll be having your containers. You have an image running. You can stop it. You can start it. Right? The similar kind of stuff again repeated in here. So here, what kubectl will do? It will go ahead and it has image. So this is my image, and where this image will be running? This image will be running again under my container. So this is what my container in here. This is generally we will happen with respect Docker. But coming to my the Kubernetes environment, this is not like your contain image and the container concept in here. So we have one more layer on top of your container. So your container is not running directly within your something like a Docker host. So here as well, your container is not running within your Kubernetes environment directly. Then how your container is running in here? Your container is running with help of one more extra layer, and that layer is called as pod. Okay, so pod is the one which will run internally within the pod. My container will run, and within my container I have my image in here. Okay, so that is how it happens within your things. So kubectl will start running what? Your pod. So when you're trying to run your pod in here, automatically your container will run internally, and you have your image running internally again inside in here. So here the pod can have one container like this, or it can have multiple containers as well, not a problem. So see here, it may have one container like this in here. The pod can have only one, just kind of things you have, or you may have similar to this one. I can have multiple containers also running on the same pod in here. Something like this. This is my container one. So I'll be having right. So this is my second container I'm having in here. So these two comes under my pod. So my container can have either one container, or it can also have multiple containers like this. So even such kind of things can be handled by a kubelet. Okay. So see how many pods I can generate, how many pods I can create per node in here. So the number of pods we can create per node is equals to 110 things in here. 110 pods you can create in here. And again, within the same pod, you can see either one container or multiple containers. Right? how many containers you can create in here. So how many containers you can run under each pod in here. So I would say that the number of the containers we can run in one pod is around 3 lakhs. Okay. So go to the Google once. So number of containers you can run in one pod, the max, how many containers can lodge in one? So let's look Google Kubernetes environment. This is different. So in Kubernetes, see, not more than 3 lakhs. So here, how many you can have such kind of things per pod? You can have, so 3 lakh container per node in here, per pod in here. Okay, so how many containers a pod can run? How many containers can run? It can run 3 lakh kind of things. 3 lakh applications can be maintained per pod. That means overall, if you see here, so total number of, I would say, total number of containers where they can run in a node. So it's totally how many? 110 pods into 3 lakhs. So it will be around something like some 33, 1, 2, 3, 4, 5, 6. So these many applications can be maintained by one pod. As I would say, these many customers can be handled by this particular waiter in here. So powerful it is. So the reason being, if you even though you create one node, that more than enough. Within one node, you can have so multiple applications you have in here, right? So now, okay, fine. So I have a pod in here and I have a container running inside them in here. Very good. So, but I would like to provide this, why we're having all this running in here, because I want to make my application to be exposed to my external world, right? Or else what is the use of running all the things in here? So who can do the particular part? How can you make sure that your application is being, your application is being accessed by my end users in here? So for that reason being, we have one more small, kind of a component called as my kube proxy. So kube proxy also has, the kind of access bin available with respect to my multiple things what you have in here, my multiple pods what you have in here. Similarly, you'll be having access to my respective things in. So what are the kubelet is trying to execute and do the things? The similar, the pods which are running in here will be having access to my kube proxy. So this one, what it will do, it will go ahead and provide the access to my end users. So this is what it actually happens in here. So overall picture, what you see in here, this is called as your node. This is called as your node in here. This is about just one node 1 in here. So similar to this one, I can have one more node available. So I can have one more node also available in here. Okay, so let me make it a little bit small in here. You can have one more node available in here. So this API server, the captain of the waiters, will try to check which node is totally busy and which node is totally free, or which node is not healthy in here, where you're not able to take your requirements or request in here. So you try to go and try to push your things, with respect to my node 1 or respect to node 2. So wherever it is, so you can have multiple nodes. So how many nodes, maximum number of nodes you can create in here? I didn't mention that. Okay, total number of contents in a node. Okay. So first of all, number of nodes we can create per cluster or per Kubernetes cluster in here. The maximum is 1000. The maximum is 1000 in here. But again, as I told you, you will not be, you will not be using all 1000 here. So as per your subscription, as per the, I would say the channel you are into, pay as you go model, the model you are into, as per the quota, you may be provided to create not more than 3. So 2 to 3 only the quota will provide, or maximum. If it is auto scale, the maximum would be 5, I believe. So we have two things: manual scaling, if you want to create your multiple nodes automatically, or you want to create manually. If you tend to create manually, I believe 3. If it's auto scaling, you can go with 5, I believe. I'll show you that when you tend to create your nodes in here. So you can have maximum number of per cluster is 1000. So where you can have a quota of just 3 to 5 only, and rest of the nodes which are being used by other customers who are using your cloud in here. Okay, so this is very huge. 1000 is very huge in here. Only for one node you have 110 pods, and again in each pod you can run 3 lakh containers. That means only one node can maintain around 330 lakh in here, 330 lakhs images or containers in here. So one is more than enough. So these many applications for for any client will not be there for sure. So one node is more than enough in here. But at the same time, you'll be provided the the access to go and try to create up to maximum of 3 to 5 in here, not more than that. Okay. So this is the information what you have in here, guys, with respect to my Kubernetes architecture. So where you can go ahead and you can work on your Kubernetes environment with respect to my things in here. So here as well, we can run some kind of commands like I want to run a pod, or I want to run a say like a kind of service. How do you do that? So what are the syntaxes or what are the command lines you followed with this? You can follow within here. So generally, I can install my Azure, you can install my CTL CLI within my system in here. And here every command starts with kubectl. So for Docker, it starts with Docker. For AZ, start with AZ. For Git CLI, start with Git. Every command. Similarly, for Kubernetes environment, every command start with my kubectl in here. Okay, so you can download it directly, kubectl within your system, and you can work in here directly in here. So see here, I'll show you a few things. It's Kubernetes, right? Okay. So this is like you have to go with. So you have to see, you have to go to the command prompt. For sure, you have to have your Azure CLI to be installed within system, as we already done that earlier when you tend to run your AZ commands, well, initial stages, right? Now we have AZ, AKS, Azure Kubernetes Services. I'm trying to install my Azure Kubernetes Services space install -CLI. So what this will do, this will go ahead and this will try to download your kubectl CLI in your machine. So see here, I'll go to my command prompt. So it will try to go and it will try to download your, it's trying to download. Let me show you what's happening in here. Copy it. So it's downloading the client to my cdel.azure.kubectl, and what is trying to download? kubectl.exe from the Kubernetes in here. So some version 1.23.5 version. So it's trying to download in here. So where it is trying to download? del.azure-kubectl in here. So this particular folder will create automatically, and under this particular one you'll be having your .exe file in here, which has been downloaded. So once you download it, here the two things you have to do is like, so go back in here and see what, oh, this is trying to come up with more commands. So let's see what it's saying. It says that please add your C user del.azure.kubectl, the same path to your search path in here, so that kubectl.exe can be found. So here it's not like, you're trying to, installing like a double click on it, installing it, and the things are happening at the back and finally installation successful. It's not the case. So here installation means is, there is already .exe file in here, so you don't need to double click or you don't need to install anything in here. Just try to make sure that this particular path where your kubectl.exe file is there should be found in here. So it's asking you go to my environment variables. So go to my environment variables in here, and here click on new and try to provide the path name. What is the path name? C drive, all those things what you have in here. Provide the path name and mention with my environment variables over here. What is that? It's gone out. Trying to place your environment variables over here and click on save button, so that whenever you try to run your Kubernetes environment, it can be easily found within the system in here. So or else what they want to go is like, so they're saying that run set path. If you do not want to add all those things in here with the going to environment variables and setting creating your own path over there, simply run this command. What is that? Set path equal to %path semicolon and C drive the same path in here. So running this particular thing, what will happen? It'll try to create an environment variable within my, within my paths what we have in here. So from going forward from there, I can go and I can, I can see my things. I can access my Kubernetes environment going forward. So we have one option, and also we have, you can use your some command line for your PowerShell, or you can saying that go to my control panel, environment variables, reopen the command window and download the client. So run set path again. See, so all the different things, the different options they're trying to provide you. Why? So that it can go ahead and recognize your Kubernetes things within your system level. So the best things what I say is that go and run this particular path so that it can be recognized. Simply running within your same command prompt, you can enter, that's it. Nothing more is be required in here. So now easily you can go ahead and you can easily the Kubernetes will be recognized by your local machine, and it allows us to run your kubectl commands in here. Okay, so for that reason we trying to provide these many huge number of options. Neither of the way it's been helpful for us to recognize your kubectl in here, a Kubernetes environment within your local machine in here. So this is the first point. So once you have installed everything in here, so now what will happen? You can mention, as I told you, you can see every command starts with kubectl in here. Kubectl or kubectl get nodes. That we have nodes, right? We are trying to create a node in here. So get node, get pod, get namespace. I talk about this all the namespace later on in here. So to have my nodes created, it's not like directly we write a command in here. But what we do, like we can create your Kubernetes cluster first. So when you're trying to say it's a Kubernetes cluster, that means that we'll be having your nodes created within your cluster. Okay, so how can you create a Kubernetes cluster now? So how can I create my nodes within my Kubernetes cluster in here? So once you have Kubernetes created cluster, then only you can come here and you can get the node information of that particular cluster what you have created. Cluster is something nothing but the group of nodes what you're trying to create in here. So being, we being so things here, we try to create only the nodes. We never bother about your master at all in here. Keep this in mind. So generally, with respect to the networking piece of my Kubernetes as well. So we know that we have a subnet, right? So there's a subnet in here. There's a subnet in here. So this is my subnet where the subnet will be created. This will be created under my main virtual machine. So I would say this is my, sorry, not machine, but it's a virtual network you have in here. Virtual network. Virtual network. So within my virtual network, we have a subnet, and under my subnet, I'll be having my nodes created. So here I'll be having my node 1 in here. Similarly, I'll be having my node 2, and similarly I'll be having my node 3. So you can create multiple nodes, as I told you, up to 3 to 5 maximum, based upon your manual scaling or based upon your auto scale. You can create multiple nodes in here. So these nodes which you have in here, these nodes what you have in here, you can create under my subnet. So where subnet can be created under my virtual network in here. So when you're trying to go and creating your Kubernetes cluster, that means you're trying to create the node level information. So you will not provide any master level information here. So what is a node, how many number of nodes you want to provide in here, and you also provide the size of each and every node. Okay. Size of each and every node in here, because see here, I may be using, if you see this particular part diagram, so this is one kind of image, that means it's one of an application here. So think that this application what I have in here, it may be a small application, so it may be, it may require just 4 GB of RAM, that's it, nothing more than that. My application will work very good, not a problem. Suppose think that this particular image in the same node, I may be having this image or this application which is running in here, maybe huge application. So I may not go with only 4 GB RAM, may not be enough for me. So it may require, 8 GB of RAM in here. So that means I need different configurations of the sizes within the same node, right? So this kind of configuration called as your agent pool. So this 4 GB of RAM comes under one agent pool in here. So when you have 4 GB of RAM, and this comes under called as one agent pool in here. Similarly, if you are trying to go with something like 8 GB of RAM in here, and this may be coming to the another agent pool 2 in here. So this is your agent pool 1, and this is agent pool 2 in here. So this is a kind of a multiple configurations you trying to handle within the same node, because you are handling lot many applications in here within the same node in here, and every application, it's not like with every application is not like you will be having only one configuration, so it may be differ as per the requirement. So all this information is what you have, you can provide within your node level while you're trying to create your Kubernetes cluster. So when I talk about Kubernetes cluster, it's all about my nodes. Okay, so what image you're trying to run in here, if anything goes wrong, from where should I pull my image? That's from my container registry, ACR, right? So ACR level information, my number of nodes you want to create, number of configurations you want to create in here, number of configurations you want to create in here, the different sizes of your VMs which are running in which your images are running in here. So everything what you're trying to create, you're trying to purely create on based upon your node level. We never touch your master, because as I told you, your master will be managed. Your master will be managed by your Azure. So from master, the things will be pushed to my respective nodes in here. But actually, you are trying to create what? Only your master, so only your nodes, but not your master. So from here, using your some kubectl, the kind of CLI in between. This is my CLI in between. Using my CLI, he is trying to push my commands to CLI in here, from CLI to a master, from master to my nodes, what I have in here. This is how it happens. Suppose you're trying to create one more cluster, not a problem. So within the same network, you can have one more cluster again. Okay, let me take out this part. So within the same network, I can have one more cluster created if you want. If you want, you can create one more cluster in here. So these two now comes under my same network. Yeah, so this is again my subnet 2. This is a separate subnet, this is a separate subnet, and this is a separate subnet. So both will be coming under same network in here. So when you're trying to create one more kind of nodes in here, so you will be having a different master. So you will not have a same master. So once my master is tagged to a nodes, so this is permanent fix. So you can't change a master in here. When you're trying to create more nodes in separate subnet, then you can have your separate master with respect to your nodes in here. So this particular nodes will be maintained by my master. So second master. So this is my, I would say, master 2, and this is my master 1. So totally two different masters you have in here. So overall, what I would say is like, so we, whatever you create, you mainly creating about your node level information. You will not touch your master at all. So this is being maintained by my Azure, where nodes are created by us, when created by the users in here, who want to have the things implemented. The same thing can be done with respect to things in here. So you can create multiple clusters, you can have multiple masters, and you can have multiple different nodes in here, where these things are being created by us, and your masters have been managed by my Azure level engineer, controlled by my Azure level engineer. So we are not there. We do not take care of your master at all. We can just take care of my nodes only. Understood? So any questions, guys? So what you do, go ahead and try to download your, I think you already have your Azure CLI with you. Download and try to run this particular command. Once you run this command, try to show you all the things what you have in here. Simply run this command again back in and hit on enter. That's it. From there onwards, you can go ahead and you can run your commands. What is that? kubectl get, suppose I want to get my node information. Get nodes. So see what it says. So nodes will be created. It's saying that unable to connect to server in here. So earlier I have created one something like VRIT cluster, where now that is no available. So I don't have any clusters now available. So when you have a created cluster is what? It's a combination of nodes putting together at one place. Cluster of servers, cluster of nodes, or cluster of the houses in a particular colony. So when we have multiple things of same kind in one place, then called as a cluster in here. So since you're trying to create multiple nodes in here, this is called as a Kubernetes cluster. So here saying that, because I don't see any, this is the earlier one what I created in here. So I don't see any cluster available in here, so that I can pull you the information of the nodes. So try to create a cluster first, try to log into my cluster, and then I can pull my information of my nodes in here. kubectl get nodes. You can see within my node level how many pods you have in here. So all those things you can get the information out by running the commands within your Kubernetes environment. Understood? So try to install this particular kubectl and keep it ready. So tomorrow I'll try to show you. See here, I have my account. I'm logging to my portal level in here. And you can go with search for Kubernetes services. So Kubernetes services nothing but internally they're trying to go with my creating of my cluster. So Kubernetes cluster in here. See the dedicated Kubernetes cluster. So when you talk about Kubernetes cluster, see they're asking you subscription resource group as usual, and see they ask you cluster name, and they're asking you see the primary node pool. See auto scale up to 5, manual up to 3, but maximum you can create 1,000. So the maximum of count can be set to 5 due to the remaining quota is selected for subscription. So we have 10 crore subscription systems within your Azure level. So these things will be used by other people as well. So you have got a maximum up to 5 only. That's what I've said. And see, node size. This is exactly same to the virtual machine what you saw. See, they're trying to also select your VMs because as I told you, since you're trying to have multiple applications can be maintained per node, you can select the sizes. But each size is being known as what? A agent pool in here. Okay. So suppose selecting this one for now. So this is like a kind of agent pool. So if you want to add more, click on next. See, this is my agent pool, the current one, what I have in here. So max number of pods 110. Okay. So basics. So it's giving error. Yeah. So I can see error gone. So now I can see my the availability is size. This is my agent pool 1 in here. If you can go if you want to create one more kind of configuration within the same node, you can add your node pools in here. When you click on add node pool, again you can see similar things, availability zones, the node count range. So how many nodes? So it's again, you can go with one only. The option segment that classes automatic size correctly, living running workloads. This is not there. This came up, I believe. So 110 pods mostly you can create per node again in here. So you have to create one more node in here. So where you can having one more agent pool in here with respect to my cluster levels. So not creating anything as of now. So you have access level, you have networking, you have integrations, advanced. We'll see how all those things one after one, tomorrow's class. Anyway. That's all guys with respect to today architecture and Kubernetes environment, the multiple nodes, creating of multiple nodes in here, where each one having their own node pools again, so you can meet and things in here. So any questions guys? Yeah, sure Chandra, you can share it, not a problem. Right then, we can wind up for today. We'll meet tomorrow with creating of your Kubernetes cluster. We'll see how it goes from there. Thank you guys. Have a great day and bye.